differs from innate immunity in that it has to respond to a new threat, a new pathogen of some sort, be able to recognize that it is different from self, and then adapt a plan to attack it. Adaptive immunity gets better the more times you are exposed to a particular antigen. That's why many vaccines will require you to have uh, 2 or 3 shots or even booster shots. Booster shots every few years help to raise the titer of antibodies that you have against a particular um, type of disease. Now, adaptive immunity begins with interactions between your T cells and with antigens on infected cells. T cells can only recognize antigens when they're presented on self proteins called major histocompatibility complexes. Your MHC markers are unique to you, as I've said in other videos. Yeah, the MHCs are very unique and they have been talked about in previous videos. But I wanted to take a few minutes and go over it one more time because I know how confusing this can be for some students. You have target cell lysis are cells that are cytotoxic T cells, or they used to be called killer T cells, but I guess that was too aggressive for the cells, so they've changed the name. All right, remember the T cells have to have some sort of receptor. So the T cell receptor is found on both the T helper cells over here and these cytotoxic T cells. Cytotoxic T cells are known as CD8s, and T helper cells are known as CD4s. What has to happen for a cytotoxic T cell to come into activity is it has to come into contact with a cell bearing an MHC type 1 molecule that contains an antigen that is not a self antigen. So this could be a normal antigen presenting cell inside the body. It could be any cell. This could be a liver cell or anything. If it has an MHC1 marker on the surface, and all nucleated cells in the body do, with very few exceptions. Sperm and egg are one of the exceptions. But these MHC class 1 markers are found on all cells, and most of them will carry self-antigen, because remember, the self-antigen is just representing what's found inside the cell, and then that's going to be expressed on the outside. So MHC1 is expressing endogenously obtained antigen. So if this is something that is not native to the cell, then it probably represents an intracellular parasite like a virus or a bacterium or a fungal disease. It's going to be something foreign. And if the T cell receptor reacts to both the MHC1 plus this foreign antigen, then you get activation of the cytotoxic T cell. What it does is it gets up close and personal with the normal cells, and if it senses that something's wrong, then it's going to cause apoptosis or programmed cell death. And it does so by getting close and releasing these granzymes and perforin enzymes, which punch holes in cells and initiate a apoptotic cell event. It's a lot more complicated than is covered here, but that's a good brief overview. Now, when we go to the T helper cells, remember they're the ones that have to eventually give permission to the B cells to go into clonal expansion. They go into their own clonal expansion. But the T helper cells have to be able to recognize MHC class 2 molecules, which are usually only expressed on professional antigen presenting cells like macrophages, sometimes basophils, or some dendritic cells can also express them. But they're expressing exogenously obtained antigen. So the bacteria is outside, it gets engulfed, chopped up into tiny little pieces, and then those pieces can be expressed on the MHC class 2 molecule. The T cell receptor on the T helper cells are going to bind to that, and it's going to initiate cytokine release. It's going to initiate the cells to go into clonal expansion of their own, and it also allows these cells to release certain cytokines that help to allow or give permission to B cells to go into clonal expansion and to actually start producing plasma cells, which are making antibodies. Adaptive immunity, we've just talked about a lot, and it's talking about these cytotoxic T cells versus the T helper cells. So you really need to familiarize yourself with both of those types of cells and what they do, and make sure you have it straight in your head. If you can say it out loud and your dog wags his tail, then you know you're getting it pretty much right. T helper cells can be separated into two major subsets. T helper cell type 1s are the ones that are going to initiate inflammation and immunity by activating macrophages. So they really upregulate macrophages. If T helper cell 1s start getting excited, then they release cytokines and they cause macrophages to become more aggressive. And when the macrophages get more aggressive, they're metabolizing faster and they're producing more heat. So that's where the inflammation comes in and the heat comes from. But now you have your T helper cell type 2s. These are the ones that are going to be specifically targeting B cells and allowing them to go into a clonal expansion and to produce antibodies. That looks like a tuberculin test. It's where they inject tuberculosis essence underneath the skin and they measure the wheel response.